Hello students, in today's session let us learn about metals and non-metals. The topics we are going to discuss are: first introduction, physical properties of metals and non-metals, chemical properties of metals and non-metals, the reactivity series, how do metals and non-metals react, and properties of ionic compounds. We have studied in class 9 that matter may be classified chemically into elements, compounds, and mixtures. The elements, on the basis of their properties and electronic configurations, may be further classified into metals, nonmetals, and metalloids. From the word metal, we get an image in our mind that it would be something hard and heavy, whereas nonmetals would be soft and light in weight. Let us learn physical properties of metals by activities. Activity 3.1. Take samples of iron, copper, aluminium, and magnesium. Note the appearance of each sample. Clean the surface of each sample by rubbing them with sandpaper and note their appearance again. Metals in their pure state have a shiny surface. This property is called metallic luster. Activity 3.2. Take small pieces of iron, copper, aluminium, and magnesium. Try to cut these metals with a sharp knife and note your observations. Hold a piece of sodium metal with a pair of tongs. Always handle sodium metal with care. Dry it by pressing between the folds of a filter paper. Put it on a watch glass and try to cut it with a knife. What do you observe? The metals such as iron, copper, and magnesium are cut with pressure, that is, by applying force, but the sodium metal can be cut easily. We can estimate the order of hardness of these metals as Fe greater than Cu, which is greater than Al, greater than Mg, Mg is greater than Na. From that we conclude, generally metals are hard with few exemptions like sodium and potassium, which are very soft. Activity 3.3. Take pieces of iron, zinc, lead, and copper. Place any one metal on a block of iron and strike it 4 or 5 times with a hammer. What do you observe? Repeat with other metals. Record the change in the shape of these metals. When metals are hammered, these are changed into thin sheets. From that we conclude, metals can be hammered into thin sheets, so they are malleable. The property of the metals by which they can be hammered into thin sheets is called malleability. Activity 3.4. Consider some metals such as iron, copper, aluminium, lead, etc. Which of the above metals are also available in the form of wires? We are able to collect the wires of iron, copper, aluminium, lead, silver, and gold, which were drawn into wires in factories or jewelry shops. From that we conclude, this collection shows that metals can be drawn into thin wires. The ability of the metals to drawn into thin wires is called ductility. Activity 3.5. Take an aluminium or copper wire. Clamp this wire on a stand as shown in figure. Fix a pin to the free end of the wire using wax. Heat the wire with a spirit lamp, candle, or a Bunsen burner near the place where it is clamped. What do you observe after some time? Note your observations. Does the metal wire melt? It is observed that the wax starts melting. The rod does not melt even after heating for a long time. This activity demonstrates that the metals are good conductors of heat and have high melting points. Activity 3.6. Set up an electric circuit as shown in figure. Place the metal to be tested in the circuit between terminals A and B as shown. Does the bulb glow? What does this indicate? It is observed that bulb glows in case of different metals, indicating that metals are good conductors of electricity.